All right, luckily I'm not too far behind, only about a week or so on this video because we did this, today's Sunday the 2nd, so it was Monday the November 20 something. It was after Thanksgiving break. It's the first thing we did after Thanksgiving break. Um, we're going to kind of speed through 4.1 and 4.2. We'll come back to some other stuff, but the chunk that I'm about to show you in 4.1 and 4.2 we've already done. This was pretty simple. When x equals 3, you plug in x and calculate, and that's when you say evaluate, which actually kind of helps us skip some stuff with synthetic division because you can do synthetic division this way also. It's called the remainder theorem. So if you're looking kind of for another way to do this, or if you see remainder theorem, that's really what it means. You're just going to use that for synthetic division. We will not, this is just, we're just going to do it this way. Add in vertical or add horizontal, this is combining like terms. Vertical means we'll just take this and put it underneath. And once they're vertical, you just match up same variable, same exponent, combine like terms. Subtract is distribute a negative to the second one and then do exactly what we just did when we added. Multiply just means foiling. So you could do foiling with the box method, foiling with the moon method. We did factor and foiling like the first week of school. Go back to the very, very beginning of this playlist and look at some of those videos. Something like this, multiply this and this and this. Well, let's FOIL this and get something, and then we'll FOIL again. That's all it is. So there's your rundown of 4.1 and 4.2. So long division, 4.3 long division. Well, let's do a little quick recap of long division. 405 divided by 6. 6 does not go into 4. 6 does go then into 40. And if you remember with long division, we look at the whole number, or we add basically one digit. Well, 6 goes into 40 6 times. 6 times 6 gives us 36. And then we subtract these numbers to get 4. This 5 then gets brought down. We kind of start the whole process over now with 45 at our beginning. 6 goes into 45 7 times. 7 times 6 is 42. And this guy is our remainder, and we usually write remainder 3. We're actually going to use this same concept with long division, except instead of really going 6 times what gets us close to 40, we'll actually be able to match up exactly. So it looks a little something like this. Man, this is a lot of writing. Try to follow along. You'll be fine. Now, I do want to say this is just one way of them showing divide. The next few problems, look for how they originally wrote it and how we ended up writing it. So x minus 5 divided into x squared plus 3x minus 40. I'm going to explain everything you see here in a moment. First thing we do is we go x times what gets me to x squared. It's a matching game. We're going to match the first part of this with the first part of this. Okay, so x times what gets me x squared? Well, x times another x, right? So that's actually going to go here. And my first question for my students was, why doesn't it go here? And I went back and I was like, well, why did this 6 not go here above this 4? They're like, well, that's because it goes kind of in that place. That's kind of the tens column and blah, blah. I said, look, this is the exact same thing. That's what these yellow lines are for. I said, this is my x to the first column. You can look. These are all x to the first. These are all x squared. These are all constants. Each one has its own column. We got to make sure we put it in the right. X times x gets us x squared. So what do we do from there? X is actually going to basically distribute backwards to both of these, and that's how we get this blue underneath. Ooh, I'm so sorry, you can barely see it. X squared minus 5x. Well, back here, once we got 6 times 6 is 36, they then said we got to subtract. So I said, all right, we got to subtract. So subtract all of this, which what happens is we're going to change signs. So us changing signs is us saying we are subtracting. Once we do that, x squared minus x squared cancel every time because, look, we said x times that. We got it to match that. That was the whole point of getting x exactly. 3 plus 5, 8x. Well, now we just have to match x to 8x. So x times 8 gets us 8x, right? So 8 times x is 8x, and 8 times -5 is -40. Again, we got to subtract, so we are just going to change the signs and combine like terms. We have no remainder, and this guy right here is my answer. Now, I am not totally sure. They were asking, like, well, why do we have to distribute to both? Why can't we just do that? Well, then this 3 has nothing really to combine with. And I said, kind of back here, we did 6 times everything that was here. I mean, and that's these green. For technically, there's a whole bunch of invisible stuff here that we, if there was like an x plus 6, we would have to distribute to it. So this x, this original x has to go to both. Same thing with 8. That's all it is. It's a matching game. So we're going to match up, change signs, bring down. Match up, change signs, or sorry, match up, distribute, change signs, combine like terms, over and over. Here's the next one. Here's another way of them writing it. Means same thing. X times x is x squared. So x times x, x squared. X times -3, -3x. Change the signs, combine like terms, bring this down. X, then now this is my new front of the line. So actually missing, let's use black this time. For the second time, x and 10x then have to match. So x times 10 gives me 10x, 10 times x, 10 times -3, change signs, no remainder. There's my answer. X times x gets me x squared. Ooh, let me go back. Something to the negative first power. If you know anything about exponents, this just means actually the exact same as this, where you take that and you put it on the bottom of the fraction bar. It's still just divide. So don't freak out too much if you see that. So x times x, x squared. And then x times -1, -1x. Same signs, combine like terms, -12. Now, x and -12x need to match. So -12 is really all we're missing. And that's really what we're trying to find. We're not necessarily trying to match. We're just trying to see what's missing. So x times x, to get x squared, I was missing an x. To get -12x, well, I have an x, I just need the -12. Distribute it back, change signs, no remainder. Well, this time we do have a remainder. Actually, we have a negative in front, which is not too bad. Negative times negative is positive, so that's how we got -a. Distribute it back, change signs, boom. -a times -10, positive 10a. Distribute, get this, change signs, boom. Oh, remainder. What do we do with the remainder? We don't normally just write R19 like we would. Right now, my answer is -a minus 10. That's what I got. To write the remainder, it's a positive 19 over whatever you try to divide by in the first place, -a plus 3. The only problem is they don't like this negative sign here, so they will take this sign, and this sign. Change all 3 of them. So that's now negative, positive, negative. Basically, it just undistributes or factors out a -1 and then puts the -1 at the very front. Oop. Sorry. There we go. Another one with a remainder. Once they got the remainder concept, it wasn't too bad. But again, they will change that to a negative. That's positive, and that's negative. They don't like having that negative in the very front. Now, going back up here again, -1 just means that's what we're doing. Now, 1 minus r, we can't really work with that. We need the variable in front. So let's switch them, just like that. Let's make sure the negative goes to the r, and that is a +1. So if you do r minus 1, your answer is going to be wrong. -r times -r, r squared. Distribute back, change signs, match up, remainder, write the remainder. Not a big deal. Once again, the -1 just means divide. Now this one was lots of fun. 3a times 2a was 6a squared. That was the easy part. Now I need 3a times something to get to 1a. Well, if you need to get smaller, you need a fraction. This fraction will always be this number divided by this number, possibly reduced. So if this was a 2 and a 6, we would still use 1/3. Distribute it back, we get this lovely fraction remainder. Wow, okay, so that's where this comes from. My answer is 2a plus 1/3 plus 29 over 3 times the 3a minus 2. Remember, what we are dividing by goes down there. Distribute. So our 9a minus 6 would actually be the bottom of my remainder. Oof. This one was fun. It was again just matching up. I did want to point out this guy right here. If you notice up here, we're missing x squared. With long division, or in the next video you'll see with synthetic division, you got to have a placeholder, because just like if I were trying to divide 401 by 3, I have to have that 0 there. That 0 represents the tens column. Well, this 0 represents the x squared column. If it's not there, it gets really, really ugly, because then this gets potentially moved over, and then you're trying to do 5x and 4x squared, and then you're all of a sudden. So just make sure, and again, you can read through this one again. You're really only matching up the first part here with the first part here, and then the first part here with the first part here, and then the x squared with this right here. So that's how I got those two numbers, and you get a crazy remainder, but honestly, it's not too bad. This one, it looks really, really scary, but just go through the motions. Do not forget this 0. Always double check. 4, 3, 2, 1, constant. Whatever your highest exponent is, count all the way down, and then don't forget your constant at the end. Yeah, I get a worksheet on this one the day I was gone, so there was no bookwork